Good morning. I am Jim Haldeman with the Lessman Instrument Company, a Kelly industrial automation company. Thank you for joining us today for our webinar, Cut Cost in Manufacturing with Automated Inline Measurement. Our presenter today is Michael Kohlmann of Vaisala. Michael has a background in electrical engineering and brings over 20 years of experience in instrumentation and with companies such as FCX Performance, ABB, Anderson Hauser, Siemens. His recent focus has been on fluid flow control applied to industries such as pulp and paper, chemical, food processing, food and beverage, life science, and water and wastewater. Today's webinar will be recorded. If you have a question, please enter it within the question chat bar, and I will see it, and I will ask the question on your behalf. Michael, please begin your presentation.
Thanks, Jim. Appreciate the opportunity. Glad to be here. We are trying to get to the next page here. There we go. So today we're going to be talking about refractometers, and as you mentioned, also how to cut costs and control costs through automation and just using the proper instrumentation for your needs. So Vaisala, we are a Finnish company. We make a number of different things, ranging from helping aviation stay safe with weather measurements, industrial measurements, which include temperature, humidity, CO2, barometric pressure, biogas, things like that. Even power with our water and oil sensors to help protect wind-powered generators. So we do a lot when it comes to weather and industrial instrumentation. And part of that is our liquids measurement group, which does refractometers for measuring the concentration of a dissolved solid. Usually it's in water or something aqueous based, but it doesn't necessarily have to be. So some of our products are even on Mars, on the rover, and they're very robust products, last years and years. And you can't just send a service group up to Mars to fix something. So that's why they chose our temperature and humidity device to be on the rover. But that just bodes well for our products' history of having very high quality. So we're going to talk, well, we already did the introduction. We're going to talk about the measurement technology of a refractometer, some of the applications. I'm going to blow through the applications a little bit, but talk more about how you're going to save costs and the impetus for using automation. So why install a refractometer? Generally, it falls into three categories. You're going to either reduce cost, improve product quality and consistency, or increase safety. All three of those are important, and generally any reason you put in a piece of instrumentation is going to somehow fall into one of those three categories. When it comes to instrumentation, you aren't purchasing a piece of equipment because it's trendy, like a new iPhone. Whether it's a pressure transmitter, a valve, a level switch, flow meter, or refractometer, again, it generally falls into these three categories which influence the purchase. So the first thing I want to talk about is refractive index. What is it? A lot of people don't know what it means, and it's pretty simple. The D in the ND is simply the measurement technique. It's the D-line light. We'll talk about that in the next slide. But when you dissolve something in a liquid, it changes the optical properties of that liquid. Specifically, it changes the speed of light. In a vacuum, a perfect vacuum, the speed of light is approximately 300 million meters per second. And in pure water, it drops down to about 225 million meters per second. It's pretty fast, but that difference is measurable. And that's what you see when, for instance, you take a straw and you put it in your glass of water. It appears as if that straw is bending. And that is simply the optical properties of that liquid. And that's something that is measurable. And it's something that's very repeatable as well. And it all depends on what is dissolved in that liquid. So for instance, if you have that glass of water with a straw in it and an identical glass and an identical straw in a second glass that has sugar in it, or soda, pop as some people call it, that bending will be more pronounced. And that is, again, the change in the speed of light caused by that dissolved product that's in that water. Some of you may be familiar with refractometers that are the handheld type. Looks something like this. You simply hold it up to the light and it gives you a scale that you can see here on the right. In this particular case, it's a salinity measurement. I use one like this for quick checks on my saltwater tank to ensure that I have the right content of salt in the water. It's about a 1%, maybe 1.5% device. This one here is actually not too bad, the VG brand, but there's a lot left to interpretation. And if you don't do it the same way each time, you may get a different result. And the other thing is, if you have a different operator using it, my wife doesn't measure this, so I don't have to worry about it, but if you have another operator that's looking at it, they'll look at that line where you see the difference between the light and the shadowed area. In this case, it's sort of a blue shadow. That interface is where you take the measurement, and it can be off by, again, as much as 1, maybe even 2%. And these do need to be calibrated because they do change, they get mishandled and so on. But the point of this slide is, as you can see, the guy on the left there, he's holding it up to the light. It's not a problem if it's seawater, but one of my points for buying instrumentation is safety. Well, what happens if this is acid? It's not a problem if it's salt water and that gets in his eye, but if it's acid, you know, he'd be in a hazmat suit right now, hopefully, and, you know, maybe have some safety goggles on and so on. You don't want to get that in your eye. So safety is a huge consideration when it comes to taking samples and, you know, maybe not automating your system. Safety would be a big concern and a reason why you'd want to automate your process. So from an instrumentation standpoint, this is a sort of a depiction of our sensors. It's a digital measurement cell, a light source, which is a yellow LED. Again, it's about 800, I think it's 889 nanometers or something like that, the yellow D-line light. It shines a light through a prism, and that prism is what contacts the process, and the measurement happens right at that interface of the prism and the liquid. It bounces around in that prism. Some light escapes into the process, and other light gets reflected and refracted back into the prism and ultimately reaches a measurement cell. It's basically a CCD camera. And that amount of light, or the actual angle at which that light returns, is what we measure, and that is indicative of the concentration of the liquid, the dissolved solids in that liquid. So we also measure the temperature, because that optical property of the liquid is very dependent on temperature. So as it cools down or heats up, you're going to get a change in the measurement unless you temperature compensate it. That change is not due to a change in concentration, it's a change in the optical quality or properties of that liquid. So it's very important that you measure temperature, and we have a temperature sensor that is right next to the actual measurement area.
Michael, we have one question. The question is, can I transmit that temperature output as a separate output?
Yes, absolutely. So we'll get into the transmitter in a little bit, but our transmitter allows two sensors, so you can have two separate refractometers, and then it has four to 20 milliamp outputs that can be tied to the sensor or the measurement, whether it's the actual refractive index or the temperature. And then we also have digital output where you could stream all of that information plus other information such as diagnostics and so on to help you diagnose issues potentially before they even happen. You can look at what we call the quality factor. It's that amount of light that comes back and sort of a confidence factor in the reading. Okay, so looking at that critical angle, that's what we call it, the critical angle measurement. As you can see in this slide, we've got the five, we'll just call it rays of light coming out of the light source. Four of them are gray or dark, while the middle one is the reddish or orangish color. That is what's depicting the critical angle, or the angle that changes as the process medium changes its concentration. That angle is going to change as that process loads up with whether it's sugar or salt or acid concentration, a higher or lower concentration. That angle actually changes, and therefore the optical image on the detector changes how much of a shadow or how much of a light area there is. And that's basically what we're measuring, is where that shadow line falls on our detector. Again, it's a CCD camera. It's actually borrowed from a barcode reader. So reuse or repurpose of a electronic device. So here's an animation that hopefully gives a better picture of what's going on. Gives you a visual. I'm a big visual guy, so hopefully this comes through. And what's important to see here is, again, as that media changes, that shadow line changes, but it shows it right there, the light reflected from a bubble is just a blip in time. It's not really changing where that shadow falls. So we have algorithms to ignore the bubbles. It's not affected by color. It's not even affected by the solids, the suspended solids that are in there. You could have a very thin liquid like water, or it could be something very thick like a syrup. We can measure anywhere from 0 to 100 Brix. 100 Brix is something you can't measure because it's essentially granulated sugar at that point, but a Brix is defined as one gram of sucrose or table sugar in 99 grams of water for a 100 gram solution. 10 Brix is 10 grams in 90 for that 100 gram solution. So as you load up the liquid with sugar, it starts to get more and more viscous. And again, we can measure, I've measured 80 Brix without a problem, 80, 85 Brix, and that's with what they call a fondant, or a cake fondant, or icing on the cake.
Michael, we have another question regarding those air bubbles. Is there a specific threshold of number of bubbles or aeration, and do you follow installation guidelines similar to flow meters off of valves or elbows with regards to turbulence?
Yep, wow, that's a really good question. So from the standpoint of installation, I like to have our sensors, and if it's a flow meter or a pH meter in a process line, I like to have them up towards the top in an elbow. If it's in an elbow at an oblique angle to the flow so that the flow hits it and then kind of takes that right turn, that helps keep it clean. It gives it good turbulence. I like the flow to be going up. If you have flow going down and you're trying to measure flow, for instance, that flow could be a partially filled pipe and you never actually see the process. If the flow is going up and it's partially filled normally, it's going to be either a full pipe or an empty pipe. So you have basically either no liquid or 100% liquid. So it's always a good idea to have the sensor mounted in the upward stream or a horizontal where you make sure that you have a full pipe. As those bubbles are coming up, they could affect it when you start to get into slug flow, but for the most part, just simple bubbles traveling through are not going to affect it. There is a threshold I would expect, where you get to a certain point, but that's going to be more of a slug flow issue rather than just a few bubbles that are passing by. There is a timeout function. I don't know what that is on our sensors, but it would have to be some substantial bubbles, and now you have a process issue rather than a measurement issue, I would think. So why install a refractometer? I hope that answered the question. Why install a refractometer? Well, a refractometer, again, measures the dissolved solids. A Coriolis can be used as well. In fact, I was a product manager for Coriolis for quite a while, and I'd use them to do just this, measure dissolved solids. But they also measure density, or they, at the heart of the measurement, it's a density measurement, which is a mass over volume ratio. So it measures both the dissolved solids and the suspended solids. That may not be a problem. It may be a problem. It may be an opportunity to use both so that you can determine the dissolved concentration as well as the suspended solids. So if you're doing corn mash, for instance, a Coriolis is not going to let you know what you have dissolved. It's going to give you everything, including the corn, the solids that are there. So it may be a good opportunity to use both a refractometer and a Coriolis and have your PLC subtract one from the other. So now you can deduce what both the dissolved and the suspended solids are. Coriolis may be affected by air bubbles. They're getting better and better every day, and the software is getting better. So there are, applications where air bubbles are not going to affect a Coriolis, but a lot of times they still are. So check with your sales guy on that before you commit to buying a Coriolis with air bubbles. Conductivity. Conductivity is a really good way, and usually a very inexpensive way to measure concentration of a liquid. The problem with it is it only measures conductive substances. So game over if you're trying to measure sugar or some hydrocarbons maybe. Even some alcohols are not going to be something you can measure with conductivity. Refractometer, again, measures all the total dissolved solids, will not measure the suspended solids. So if that's something you want to do, you have to look at a different technology or potentially two technologies here. Not affected by bubbles, color, or suspended solids. So what are some of the industries? Pulp and paper is a big one. Food and beverage, I'm the Midwest regional manager, so food and beverage here in the Midwest is huge for me. Chemicals, ranging from measuring the concentration of an acid or a sucrose solution going into farm. Semiconductors is another big one, looking at the etching process or the cleaning process. Metals and mining, life science, there's just every industry can benefit by looking at the concentration of a liquid. And again, many different ways to make that measurement. Make sure that you choose the appropriate one. Application, mixing and blending, dissolving, evaporation. We're talking about saving money here, and evaporation is a huge one. Evaporation requires energy. You're putting energy in to drive off the moisture. So what are you doing to do that? You're heating it up. And you want to hit a set point to make sure that you get the product that you're looking for, the concentration that you're looking for. If you don't heat it up enough or long enough, you don't get to that point and you're not giving the customer what he wants or giving the next operation in your manufacturing process the proper product. Conversely, if you heat it up too long, you could be evaporating off more water, and now for that same volume, you have a much higher concentration that could affect your end quality or cost money because you're giving away product, not only giving away product in a higher concentration, but you've also wasted all of that energy in the process. So there's a lot of different applications and reasons why a inline refractometer is a really, really good choice. Some of the units of measure: concentration by weight. So let's say you're making acid, you're looking at the concentration of that acid, or sodium chloride, for instance, you want to maintain 26% salt. This is a really good measurement for that. We do that all day long. Liquid density, again, density is a mass per volume, but if it's only a dissolved solid that you're looking at, we can do the density as well. Brix, mentioned what that is, what the definition is. Total solids, I'm not a fan of that being put in here because it can't measure total solids unless they are all dissolved. So the next point there, total dissolved solids, is what we measure. If there are any suspended solids, we will not be able to measure that. Then you got Plato and Baume. Those are older terms. Some people still use them, but we can measure that. We have, by the way, we have special chemical curves in the hundreds for numerous chemicals, numerous processes. And if you have a special chemical curve that you need, that you know, hey, the refractive index of 5% is X, refractive index of 10% is X, and so on, we can actually build you a curve to give you a percentage reading. Last one here, Oxley. I'm not even sure if I'm saying that right, but that is a measurement of wine. It's used in winemaking, looking at the concentration of, I believe it's what's left over in the grape making process when they squeeze more out of the grape. Not sure, but it is in the winemaking industry. So here's a picture of one of our sensors. This is our sanitary compact model. This is what I sell the most of, and not only because of food and beverage. This sensor can be used in a lot of applications. The beauty of this one is the way that it gets mounted into the process. It's a hygienic tri-clamp, tri-clover, however you want to call it. It's just super easy to remove from the process, to do any kind of maintenance on it, cleaning, swapping it out if you want to put a spare in there. These generally don't need to be taken out if they're mounted properly and with enough, as you mentioned, Jim, turbulent flow. High velocity and turbulent flow is your friend when it comes to a refractometer. It basically keeps the tip of the sensor, that prism, clean. So this is, again, our 3A version, EHEDGE certified, full range, so 0 to 100 Brix. And yeah, it's basically maintenance free. The only thing you want to do is make sure you keep that sensor clean. So that right there cuts down on a lot of costs from a standpoint of maintenance. Here's a similar version, but a longer snout. This allows you to get into the process further, potentially into a larger line size, maybe through the side of a tank, just another version of that particular sensor. Again, it is a hygienic design, uses the tri-clamp, tri-clover fitting, and very easy to put into and out of the process. The next one, this is our general purpose. It's a flange mount, and you can see there's a parallel pipe to the snout of the sensor. Not sure if you can make that out on your screen, but what that is a cleaning system that's built into this. It's an option, but it is something that you can order, and it proactively keeps the sensor clean. It shoots either a shot of water, high pressure water, or steam across the sensor, and it prophylactically keeps that sensor clean. And it's a lot easier to keep a sensor clean than it is to clean a sensor once it becomes dirty. So if you have a process like chocolate potentially, or something where you're going to get a buildup, a lot of times it'll be in pulp and paper where there's a problem with coatings, some chemicals and so on. It doesn't introduce a lot of water. It's on the order of maybe 50 milliliters of water per cleaning, but it's very effective at keeping it clean. And that is something that's user adjustable. So if you find out that you don't need to clean it as often as is set up right out of the box, you can change that and change the frequency and the duration of each of the cleanings.
Michael, there's a question regarding this. Is there some type of diagnostics that's run in your transmitter so that you can see what a value may be, and then when that value changes to X, that you would actually run that cleaning cycle?
Yes, so we'll talk about the transmitter in a few seconds here, but there is a number of diagnostics on these sensors and transmitters. That there's one, it's an optical image, and it actually shows a sort of a graphic depiction of what the instrument sees, sort of I don't know, an insight into what the instrument sees. If that changes significantly, you're going to get an increase. If there's a coating, for instance, it's going to change three different things. It's going to change the way that optical image looks, and now the operator, if they see that there's an issue, or they just go up to the screen, they can tell what state this is in by looking at that optical image, looking at the amount of power that the LED is pushing to get a stable image, and then also look at what we call the quality factor that I mentioned earlier. That diagnostic screen helps an operator determine, and helps our service people determine, the health of that sensor and how clean it is. Again, it's all coming down to that it's within one wavelength of the light that's coming out of that LED that the measurement is made. So even a piece of Scotch tape put over the face of the sensor, that thickness will influence the reading. So you want to keep that surface clean, and the diagnostic page very much helps in diagnosing a problem and coming up with potential solutions to it. And again, part of those solutions are turbulent flow, higher velocity, and using this cleaning system if needed, and then tweaking that cleaning system's duration and how often it fires to keep that sensor clean. But those are all things that you can output with the transmitter as well, to run that into your PLC if you'd like, to help trace and show what's going on with the system. So this is our safe drive. This is a specialty sensor used for pulp and paper. It allows you to, people call it hot tap, but hot tap is how you put it in initially. But it allows you to withdraw the sensor in a pressurized pipe, so you don't have to shut down the process. Again, another way to save money in your process is to not shut it down. Many of these processes lose thousands and thousands of dollars if they shut down for just a half a day to do any kind of maintenance. This device allows you to pull the sensor out while the process is running and do it safely. We used to have a system that required something on the order of 20 steps, unique steps that needed to be done, and this all allowed you to pull that sensor out safely we've reduced that now to, I think it's 7 steps. So it's much easier to pull it out, much safer to pull it out. And as long as you follow these steps, it will allow you to pull it out safely without any potential for process to be, leaked out of the line while it's under pressure and running. Again, another way of saving costs or reducing costs here. Every minute that you are not able to produce something because you had to shut down the line for maintenance or whatever it happens to be, it's costing you money potentially. This is the Indigo 520 transmitter. All of those sensors that I just showed you connect to this transmitter. The screen that you see there is the trending. So you can trend by minute, 15 minutes, hour, 12 hours, day, and then 7 hours. So right on the screen, you can look at historic values. It also allows you to change that main screen to show 1 value, 2 values, 4 values, or 6 values. So at a glance, you can see what's going on with your process or multiple processes. In fact, you can use one of our refractometers to look at the process and also use one of our temperature and humidity sensors to look at what the environment is outside of the process. So in a room, for instance, where you are drying crackers maybe after, I don't know, that's maybe a bad example, but you want to control the humidity in the room, you can use a Indigo 520 transmitter for 2 completely different things. One to monitor the process and another to look at the room, what that temperature and humidity is. So here's a screenshot showing sugar concentration for 2 different lines. So this has 2 different sensors. And again, you're looking at the concentration in Brix and then the temperature. And that shows C, temperature in degrees C. You can change that to degrees F if you'd like. Number of different things that you can see on this, as well as you mentioned, Jim, you can hit the right arrow right above the Vaisala logo there. You can hit the right arrow and go over to a screen that gives you the diagnostics. Very helpful in looking for problems or preventing problems. Again, saving money is all about keeping your process up and running, and the diagnostics is a huge part of that. Again, here are some of the applications. I don't want to go over any more applications here, but food and beverage, again, is something huge. We have a number of different application notes for literally over 100 different applications. So application notes showing a brief overview of what the process is. One of my favorites is the brewing process. You can see here, this is sort of a schematic of what's going on in the brewing process. And in every one of these, where you see the little red cap, that's our sensor. That's a point where it may be worth taking a measurement and taking the guesswork out of that measurement, making sure that you're getting the right concentration, making sure that you're doing the full conversion of starches into sugars. And then once you're doing the fermentation, that you're converting all of those sugars into the alcohol that you're looking for. The whole point is taking the crushed grains and converting it into alcohol. And it's all about the efficiency and what you're extracting out of those grains from a standpoint of sugars and starches and converting it into a useful product, which at the end of the day is the beer, right? So it's all about optimizing your process. And obviously you're going to want to know temperatures here, flow rates. There's all kinds of instrumentation that you can use. So it's not, I don't want to make this just a commercial for our refractometer. It's about all kinds of different products. Again, I mentioned what the impetus is for putting in a piece of instrumentation. If you have a level device that's measuring the level of a tank, it's a great control. Measuring, 20%, 30%, 40% fill in a tank, that's great control. And the only problem is if that goes down, now what? Maybe you have a false sense of security, but if that goes down, you have no way of preventing cavitation of a pump, for instance, or looking at the overfill of that tank. The overfill of a tank would cost a lot of money in cleanup, cost a lot of money in the product being lost. Safety risks, huge safety risks. So in addition to that level controller, why not put a point level device up at the top to prevent a spill, or at the bottom to prevent a pump from going dry and costing thousands of dollars for a new pump because you cavitated it. So a lot of different reasons for putting in automation besides just making it easier. A lot of savings and costs that potentially aren't even thought about. So whey protein, I mentioned drying. In this application, drying is or evaporation is a huge expense. There's a lot of money going into that, and making sure that you control that evaporation properly, that you evaporated enough but not too much to control those costs. It's a very, very big savings potentially for some customers, for many customers. Applications in chemicals. Again, if you're making chemicals for in-house use or you're selling them, you want to make sure that you're selling the same product all the time. If you're not giving them their money's worth, they may look for another supplier because you're supplying 10% instead of the 12% they're expecting. Or you're giving it away because they're expecting 10 and you're giving them 15% because you aren't looking at the concentration throughout the manufacturing, or concentrating or diluting of those chemicals. So just another place to look at automation. Again, we have all kinds of application notes that you can look at. But again, why are we looking at refractometers, or as I put here, any piece of instrumentation for that matter? You're going to want to reduce costs, improve product quality and consistency, or increase safety. Some of those examples: reducing cost. Efficient automation typically lowers the operational cost. It increases the yield, usually, not necessarily, but also reduces waste. You aren't redoing a process because you overshot or undershot. Many applications, you don't need to worry about that too much because you can either add more water or concentrate it a little bit more. But if it's a batch process, there was one customer I ran into that if their process isn't done correctly the first time, there's no rework. And a lost batch is on the order of $100,000. The cost of a refractometer would be paid for many, many times over with one lost batch. Lower energy usage. I talked about evaporation, but you're spending a lot in pumps and opening and closing valves and moving product around. Why not make sure that you get the best use of your process and save money in doing that? The other nice thing is you get, and again, this isn't just with a refractometer, but it could be taking pH samples and so on, where you get an immediate response to any deviations in quality. You're going to know it right away. And if you do it correctly with the PLC, you can correct them all automatically rather than having manual intervention. All of that translates to reduced costs and potentially lowering raw material usage. Instead of adding X amount of chemical, you're able to add X minus some of that chemical. And then, of course, I just mentioned that reducing waste or rework, recalls. You want to make sure that you have the same product in appearance, the mouthfeel, the taste, the color, you know, everything. All of that comes to the quality of the product, really. But you know, you could have all three reasons all in one. In this case, rework, that's going to cost you money. But if you're giving a poor quality product, that's going to be, you know, coming down into the customer's perception of what your product is, and it could prevent lawsuits even. Interface detection, we do a lot of that where you are running multiple products, and rather than running that product and then rinsing out the line for a long period of time just to make sure that it's rinsed out properly, you could potentially use a refractometer or a conductivity meter to look at that interface between the two products. And if there's a discernible difference between them, this is a really good idea to save on costs right there. Where you aren't wasting product, you're able to determine the exact point at which that process changed from one product to the other. CIP rinsing, for instance, is another one where you aren't just rinsing based on time, you're doing it on actual measurement of the product, making sure that you now have clean water rather than soapy water, and you stop it before you waste all of that water. And let's face it, a lot of times that water that you're using has to go to waste, has to go to your wastewater treatment plant, for instance, and now you have to treat that. So that becomes another expense. Nearly every process has a wastewater treatment plant of some sort, or at least looking at it before it goes out to the city. In one case, I had a customer who was working with fruit and fruit juice, and they had an upset in their process, and they wound up dumping that high loaded sugar wastewater into the local municipality. They wound up getting shut down because they couldn't discharge anymore into that municipality until they found and corrected the problem. They installed not just one of our transmitters, one of our refractometers, they installed two for redundancy. And within a week, they found a problem with their cleaning crew putting in cleaning solution into their waste stream. And they pinpointed it because it was run into their PLC. They pinpointed it to the precise moment that the cleaning crew swept the cleaning solution into their wastewater system. That's how quickly it was able to point out a problem. So online detection of a wastewater stream is potentially going to save you a lot of money in shutdown and levies and fines and so on. So we talked a little bit about improving consistency. Well, reselling chemicals is a big one. You want to make sure that you're giving the right product to the customer. Food and beverage, again, if you're concentrating or making fruit juice from concentrate, you want to make sure that you have the same consistent quality all the time. If your customer gets, for instance, orange juice that isn't the same sweetness each time, they're not going to want to buy your product. So you promise you promise a product quality, you want to provide that usually. Grab samples. This will drastically reduce or even eliminate the need for grab samples because you are measuring right online with very fast, actually immediate response, and you can do corrective measures to fix it or automate it running it through a PLC. Safety is a big one. Many people don't even think about it. This is something I preach all the time. If you have to take a sample, a grab sample, it could be potentially unsafe, not just from the product itself, but the temperature of the product. If it's water that you're taking a sample of, probably not a big deal, even if it's boiling. It'll cause a burn, yes, but that burn isn't going to be as bad as if it's something like a sugary syrup. That won't be that easy to immediately get off of your skin, so it'll continue to burn. Or if it's an acid or a caustic or some other chemical, that'll burn. So grab samples are typically unsafe. It's not necessarily that you're going to eliminate them, but there's a potential that you could. The other thing is they're time consuming, inconsistent due to human error. This is an egregious example, but you can't take a grab sample of temperature, for instance, obviously. But in a case of taking a sample of pH, for instance, that pH can change from the moment it left the process line and is now in the lab. And maybe the person taking that grab sample stopped off at the cafeteria to grab a soda while he does the pH analysis. Obviously the temperature and the pH could change. Same thing can happen with a refractometer if they're not taking it within the process. By the time it gets to the lab, the temperature could change, and now things have changed. Even evaporation could happen. So inconsistency due to human errors where they aren't measuring at the same time interval. Again, potentially hazardous. And by the time you take that sample, it may be too late. If that sample takes 20 minutes to take and get the results back from the lab, a refractometer could have given you that information immediately. You could have taken corrective action, whereas the horse may already be out of the barn at this point. So a couple of things in closing here. Belt and suspenders is a fashion faux pas, but if it's critical and safety is a concern, redundancy is important, you might want to put two sensors in, whether it's a pH sensor, a pressure sensor, or a refractometer. Don't underestimate the need for spares. Having a spare on the shelf, even if it's something that is bulletproof, don't underestimate damage. Somebody coming up there and ripping the wires out because they were trying to climb up on the side of the process, and they pulled the wires out, and it directly pulled out, components on the printed circuit board, for instance. Having a spare is important. You could have chunks going through the sensor or through the process and strike the sensor and crack the sapphire prism on our refractometer. Have a spare. If it's critical for you and you don't want to have your process shut down, spares are essential. We mentioned early detection in the waste stream. A refractometer can help, but it's non-selective. It won't measure what's going on. It'll alert you to a product. It can't tell you, hey, I have sugar, or I have cleaning solution, or I have acid in there, but the refractive index will go up. You now have to identify what that problem is. Wasted runs cost money. We all know that. If you have to throw out a batch, you not only wasted money, but there is an environmental impact. You wasted energy. There's a slew of reasons why you don't want to waste money on a run that just isn't going to work out. One of the things I always say is you can't control what you don't measure. So automation is a really good way to cut down on costs, make sure that you have a good, consistent process, and in the end, a very good and consistent product for your customer, whether that's an internal customer or a customer that purchases this retail or on the open market, whatever it happens to be. We all have customers, and you want to make sure that you provide a consistent product and save money doing it. It all adds up to money. That's all I can say here. I hope that helps.
Thank you, Michael, for your insight with the benefits with using inline real-time measurement to control costs. We don't have any additional questions at this time. So should anyone have any questions, feel free to reach out to myself or Michael. There's my contact information. You can reach out to me with any of your questions, and I'll be happy to work with you and work with Michael appropriately to answer your questions. So with that being said, Michael, thank you again for your expertise, your time. Thank you for those who logged in and participated. And I want to wish everyone a pleasant day. Thank you again for joining. Good day.
Thanks, Jim.
Thanks, Mike.